In this lesson, I want to get into the Scala vector class. And to do that, I'm going to show a blog post from my website where I show over 170 different examples of how to use a vector. And to do this, I follow the CRUD acronym that I've been using so far, CRUD, and where CRUD stands for create, read, update, and delete. So that's what I'm doing in these examples here is I show how to create vectors, how to read a vector, which means how to access vector elements, then how to update the elements, how to delete elements, and then even more. Scala has so many methods that there's a more section right here. So the vector class is really, really important. It's the general purpose immutable index sequence in our Scala application. So immutable means that the sequence elements can't be changed, and index means that you can access the elements very quickly by their element number or their index. So if you want to access the first element or the 1,000th or the 1,000,000,000th element, that's much, much, much faster. It's only a couple of hops programmatically to find the 1,000,000,000th element, whereas a linked list, you'd have to traverse 1,000,000,000 elements just to get to that one. So just as the array buffer is the recommended go-to class for mutable index sequences, vector is recommended as our go-to class for immutable indexed sequences. And this is mentioned in the Scala doc, which you can see here, where they mention that vector is a general purpose immutable structure, and it provides, if you read through all that, it provides very good balance between fast random selections and fast updates. And because of that, they're the default implementation of immutable index sequences. And now, before we get into the following examples, I want to make this note that you see here at the top that because a vector is immutable, just imagine that every time I call a method on it, you remember you have to assign the results of that method to a new variable. So I don't do that in all the examples that follow because it takes so much space. But just remember that you can't mutate a vector, so anytime you call a method, you have to assign the results to a new variable. So the first thing I show is that if you want to create a new vector with initial elements, you do it as shown in these examples here. So I'll switch over to the Scala REPL, and so to create a new vector, you can just say A equals vector of 1, 2, 3. So that creates a new vector A, and similarly, I could do that with strings, so I could say something like foo and bar as a couple of strings. Like that. So that creates a vector of strings. And then in these sections, I create several more examples. So at this moment, I don't have a person class, but if I did, we could create a vector that contains these person elements. And in this section here, I show how to create a vector. There's a formatting issue over here, but let me just go ahead and do this. So what I can do is copy this, paste that in. So this code creates a trait, an animal trait, and then dog and cat both extend that animal trait. So then what I can do is create this little animal house. Let me copy that right there. And then I could say, I have a vector, and then I have a dog named Rover and a cat named Felix. Okay, and I'm adding some extra spaces there to make that easier to read. And you can see actually that the Scala compiler is smart enough to say, oh, okay, you're including a dog and a cat both in this vector. And because of that, I'm going to make this a vector of animal. And had Scala not done that for you automatically, you could do that yourself by explicitly declaring, I want this to be a vector of animal. This example would be even better if I had implemented multiple traits up here. So let's just say has a tail. So now I could say, go back up here, and we could say extends animal and has tail, and this one has tail. And that works out well. So now when I go back up here to this original one right there, because dog and cat both extend animal and has tail, we're not going to get the same example here when I hit enter. Okay, and in fact, this is what we get in Scala 3. So we get something that implements that. And so if you didn't want that, that's the use case where you come up here and you say, I just want this to be declared as a vector of animal. And there you do that. In this next section, I show how to create an empty vector. So this would be an empty vector event. And then you could add other elements to it later, as I'll show here shortly. So you start with an empty vector and then you add elements. In this section, I show how to create a new vector by populating it with initial values. And I show a number of different ways to do this. And this syntax here is basically one of my favorites, really, 1 to 5. I prefer 2. I prefer the keyword 2 instead of until, because I think it's more obvious. 1 to 5 means you're going to get all numbers 1 to 5. And then when I read 1 until 5, it's a little vague. I'd have like a 50-50 chance of getting that right as far as what the values would be in that. Whereas 1 to 5, I would say, okay, that's going to include the numbers 1 to 5. So this creates a range. If I just copy and paste that there, you'll see that this is a range right here. It's called a range there and a range there. And then so what you do is you start with that range and then you do a 2, and you could convert it to all these different types. And then I'm just going to say I want to convert that range to a vector, which is what I do there. As I go back here, this shows a number of different things you can do with ranges. All of these use ranges. And the interesting things to note are you can skip over elements. So you can say 1 to 10 by 2, and that'll give you these odd numbers here. You can also use characters when you're doing this, creating ranges, and you can use characters and then use by 2 here as well. This section shows 2 other ways that you can populate initial data into vectors. So the first one is with the fill method. You can see how that works right there. Copy that, paste that one in there. That creates 3 instances of foos. If you wanted 10, 11 of those, you would do that. So you get a whole bunch of foos. And then tabulate is kind of fun because it says this first parameter is how many elements you want. And then this is an anonymous function right here that you pass in, and you say, this is how I want you to create those elements. So I want 3 elements, and you can kind of tell from what it's doing here, where it's passing n and then saying n times n, that it starts with 0 as the first element. So then that's how you get this 0, is it tries to run this algorithm, but 0 times 0 is 0. Then you get 1. So 1 times 1 gives you this 1 here. The next one is 2. So then 2 times 2 gives you this 4. And then in the second example, I show that I want 4 elements in the vector that's created. So then we get down to the number 3, and that's where the 9 comes from. The 3 times 3 will get you the 9. So you can use any algorithm in here that you want. And the key is just knowing that it starts counting at 0, then goes 0, 1, 2, 3, etc. Next is how we read vector elements. And really what I mean by this is how we access the vector elements. And you can see this is consistent with the other types that I've shown before. So let me copy that and come over to the REPL, clear that out of the way. And then we say names equals that, and then the way we access elements here. So the first, or the 0th element in the names vector is Bert, and then the first element is Ernie, and so on. So that's one way to access elements. And another way, which I do show next there, is with a for loop or for expression. So we could say for, and in names, do print line n, and you can see that prints those 3 values from the initial vector. And then a second example would be, let me just start that over again. So then I'll say, how about uppercase names equals for n in names yield. So I'm going to yield a new value instead of doing something. I'm going to yield something. So I'm going to say yield. So n is each name. So then I'm going to say, capitalize. There we go. And to be clear about my hesitation there, what I was doing was trying to think about the problem. So for name, probably would have helped if I call that name. So I was trying to think what's going on here. So I'm actually, when I'm over here, you're yielding one name at a time. So you're saying, okay, for the current name, I want to call the capitalize method. So whenever you're writing an algorithm with yield over here, you're just worried about the individual element in the vector, and then the for yield combination takes care of that looping for you. And since I'm in this neighborhood, I will keep mentioning this again and again, probably throughout this course, but that type of loop, just a real basic for yield loop, is the same as if you had called map, and then we could say name to, so for each name, I want to call name.capitalize, and then remember that because we're only referring to name over here one time, we can do that. So this for yield expression and this map method and this map method all yield the exact same result, which is, it's a bit of an aside, but I wanted to show that while we're right here.